The moment a supercar stops being just a machine and becomes a battlefield between engineering and obsession, something changes. Because at that point, it's no longer about speed. It's about truth. And right now, in a workshop far away from Bugatti's controlled environment, that truth is being pulled apart piece by piece. A car that was never supposed to be split in half has been split in half. A structure engineer said required factory conditions has been dismantled on a basic lift with hand tools, cameras rolling, and a small team refusing to accept limits written on paper. And at the center of it all is Matt Armstrong. Not a manufacturer, not a billionaire collector, not a corporate engineering team, just an independent builder with one dangerous advantage. He doesn't stop when something is called impossible. The Bugatti Chiron project was supposed to be a rebuild. That's what everyone thought. Fix the crash damage, replace what's broken, put it back together, move on. But that idea collapsed the moment the teardown revealed something unexpected. Because the damage wasn't isolated, it wasn't simple, and it wasn't honest in the way everyone assumed. The deeper they went, the more the car resisted being understood as just damaged. It was engineered in layers, and those layers told a different story. A story Bugatti never intended to be examined outside their walls. Now the car sits split apart. Front section separated from rear. Drivetrain exposed like an autopsy. And what should have been a straightforward repair has turned into something else entirely. A forensic investigation. Back in Miami, the tone has shifted completely. The excitement of destruction is gone. Now comes the part that breaks most projects like this. Rebuilding. Because rebuilding is where reality hits hardest. Every decision now matters. Every part now costs time, precision, and sometimes hundreds of hours of fabrication. The gearbox mounting bracket is the first problem that refuses to behave like a normal repair. It's a cast aluminum component, small in size compared to the rest of the Chiron's architecture, but critical in function. It connects the engine and transmission structure. It carries load paths most people never think about. And in this case, it was damaged in a way that didn't make sense at first. The crash was front-end. Yet this rear-mounted component was flagged. Not by Matt, not by the builder, but by Bugatti themselves during inspection. And that's where the questions began. Because why would a factory inspector focus on a rear gearbox mount after a front-end impact? Unless they already knew something. Something they didn't explain. Something they've likely seen before. Matt starts asking the same question anyone in his position would ask. How did they know to check there? Why remove undertrays? Why investigate a hidden rear structure unless there was precedent? Unless this wasn't the first time. Unless this wasn't unexpected at all. That thought changes everything. Because if a manufacturer knows a part fails in certain crash conditions, that changes how you interpret the entire write-off decision. Not as beyond repair, but as not worth repairing. There's a difference, a very expensive difference. Meanwhile, the rebuild continues forward anyway, because stopping isn't an option anymore. The gearbox bracket is now being scanned in high detail, every surface captured, every stress point mapped, not to replicate it, but to improve it. And that's where things start to get uncomfortable for traditional manufacturers, because casting has limits. It forces uniform thickness. It forces compromise in geometry. It forces engineers to design around production, not perfection. But CNC machining doesn't care about those limitations. It removes material only where needed. It reinforces stress paths instead of averaging them. It builds strength into the logic of the part, not just its shape. And suddenly, the replacement part being created in this small independent workshop isn't just a copy. It's an upgrade. Stronger than factory, cheaper than factory, and potentially better than factory. That's where the real tension begins. Not between man and machine, but between freedom and control. Because if a crashed hypercar can be rebuilt outside the manufacturer's system, if damaged non-repairable components can be reverse engineered, if factory-only parts can be improved independently, then what exactly defines a write-off anymore? Elsewhere in the build, another evolution is happening. The exhaust system is being completely reimagined, not replaced, rewritten. The original Bugatti system was designed for compliance, noise regulations, global market approval, comfortable delivery of power without overwhelming sound. But the W16 engine was never built to whisper. It was built to dominate. So the system is being re-engineered for character, not noise for attention, but sound that matches the scale of the machine. Valvetronic in Austin takes the original exhaust for scanning. The goal is not destruction of engineering integrity, it's refinement. Emissions components remain where required, but restrictive secondary elements are removed. Flow is increased, tone is unlocked, and the car begins to sound like what it actually is. A mechanical event, not a regulated product. Back in the workshop, radiators arrive damaged but not defeated, bent, punctured, distorted from impact, but not impossible. And that's the key difference in this entire project. Nothing is treated as impossible, just untested. Every component gets that same treatment. Measure it, understand it, rebuild it, or improve it. The philosophy is simple. If Bugatti built it once, it can be rebuilt again, and maybe even better. As the chassis sits split apart, the reality becomes clearer. This isn't just a repair anymore. It's an interrogation of automotive authority, a question being asked in real time. Who really owns the knowledge locked inside these machines? The manufacturer or the people willing to rebuild them? And somewhere inside that question sits the gearbox bracket. Small, cost, overlooked, but now central to something much larger. Because if that part was known to fail, if that failure was predictable, if inspectors already knew where to look, then the story of this Chiron changes completely. It was never just damaged. It was understood, just not explained. And now, it's being rebuilt in public, piece by piece, decision by decision, until the version that returns to the road is no longer just a Bugatti Chiron, but something closer to a challenge to how modern hypercars are defined, and who gets to define them. The rebuild doesn't slow down, it just changes shape. Because once a project reaches this level, it stops being about individual parts and starts becoming about systems. And every system in this Bugatti Chiron is now under microscope, not just repaired, not just replaced, reinterpreted. Back in the workshop, the split chassis sits like something suspended between two lives. One half still carries the identity of a hypercar that once tore down highways at speeds most people only see in simulations. The other half looks less like a car, and more like a mechanical anatomy study. Cables exposed, mounting points visible, structural logic laid bare. And in the middle of it, the gearbox mounting bracket becomes more than just a broken component. It becomes a focal point of the entire rebuild, because the deeper Matt looks into it, the less it feels like a random failure, and the more it feels like a design behavior. Cast aluminum doesn't fail randomly. It fails predictably. It fails in patterns. And patterns, in engineering, are never accidental. They are learned, documented, and sometimes quietly accepted. The idea that Bugatti inspectors specifically flagged this rear-mounted component after a front-end crash stops being a curiosity and starts becoming a signal. Because in high-level automotive engineering, nothing is inspected without reason. Time is too expensive, processes are too controlled, and decisions are too deliberate. So if someone opened the underbody panels, if someone traced energy paths through the drivetrain, if someone pointed at a rear gearbox mount after a frontal impact, then the logical conclusion is simple. They weren't guessing. They were confirming. And that shifts the entire narrative of the crash. What looked like a single event accident starts to look like a known failure scenario. A stress path Bugatti is already mapped. A structural weak point that appears under specific energy conditions. A control breakpoint designed to protect the drivetrain by sacrificing itself. That's not bad engineering. In fact, it's the opposite. It's intelligent crash management. But intelligence comes with consequences. Because anything that can be predicted can be reproduced. And anything that can be reproduced can be repaired. The question is no longer whether the part failed. It's whether the system allowed it to fail exactly as intended. And if that's true, then the Chiron was never beyond repair. It was just outside the manufacturer's willingness to repair it. That distinction is where everything changes. While that debate grows in the background, fabrication continues forward in the physical world. The new gearbox mounting bracket is now being developed not as a replica, but as a reinterpretation of function. The original car's design has one unavoidable constraint. It must cool uniformly during production. That means equal wall thickness. That means structural compromise. That means material exists in places it doesn't need to be, and is missing in places it might benefit most. It's not a flaw. It's manufacturing reality at scale. But CNC machining removes that reality entirely. Now stress maps define geometry. Load paths define reinforcement. Weak zones are eliminated before they exist physically. The part being created is not shaped by mold. It is shaped by data. And when you start designing parts that way, something subtle but important happens. You stop asking how was it made, and start asking how should it behave. That shift is what separates factory production from independent engineering evolution. Meanwhile, in Texas, the exhaust system begins its transformation. The original titanium assembly is scanned down to microscopic precision. Every bend, every expansion chamber, every restriction point. Because this isn't just about making noise. It's about understanding how sound was originally controlled. Bugatti's exhaust system was never designed to unleash the full identity of the W16. It was designed to contain it, regulate it, make it acceptable in a world governed by regulations, emissions targets, and customer comfort expectations. But the W16 engine is not a polite engine. 16 cylinders firing in synchronized chaos is not supposed to be refined. It is supposed to be overwhelming. So the redesign doesn't aim to destroy compliance. It aims to negotiate with it. Catalytic converters stay where legally required. But secondary restriction points disappear. Flow paths are opened. Back pressures recalculated. Acoustic tuning shift from suppression to expression. The goal isn't louder for attention. It's honest sound. Sound that reflects what the engine actually is, not what regulations allow it to be. Back in Miami, the chassis alignment becomes the next major challenge. Because once a hypercar is split, even millimeters matter. Not in theory. In reality, a deviation of even a few millimeters across mounting points can translate into stress under load that will eventually destroy the structure. So the team doesn't guess. They measure, then remeasure, then scan again. Every mounting surface is digitized. Every structural plane cross-checked. The car is no longer treated as a vehicle. It is treated as a reference dataset, and that dataset determines whether the rebuild succeeds or collapses under its own precision requirements. The irony is obvious. Bugatti builds these cars with tolerances so tight that only factory systems are supposed to service them. But here, outside that system, those same tolerances are being matched, and in some cases exceeded. The radiators arrive next in the chain of reconstruction. Bent fins, compromised cores, impact deformation that would normally trigger replacement orders. But replacement orders require manufacturer access, and manufacturer access is exactly what this project refuses to rely on. So instead, each radiator is broken down into its structural truth. What is damaged is isolated, what is intact is preserved, and what can be rebuilt is rebuilt with surgical precision. The idea that a hypercar component is too complex to repair begins to dissolve when you stop treating it as a sacred object and start treating it as an engineered system. Every system can be understood. Every system can be replicated. And every system, once understood deeply enough, can be improved. That philosophy is starting to define the entire rebuild. Not restoration. Not recovery. Evolution. Even the wheels become part of that philosophy. Because when you're dealing with brake calipers that are physically enormous and thermally aggressive under load, wheel design stops being aesthetic. It becomes functional geometry. Clearance isn't optional. It's survival. So the wheels are not designed visually first. They are designed structurally first. 3D scanning captures brake geometry down to millimeter accuracy. Then A-flow considerations are introduced. Then load distribution. Then material stress behavior. Only after all that does appearance enter the equation. And by the time it does, the design already has identity, because function has already shaped it. At this point in the rebuild, something subtle begins to happen inside the project. The line between repairing a Bugatti and questioning Bugatti starts to blur. Because every time an original part is analyzed, a question emerges. Why was it designed this way? Why this thickness? Why this material? Why this constraint? And sometimes the answers are obvious. Manufacturing, cost, regulation, scale. But sometimes The answers are not obvious, and that's where the discomfort begins. Because when independent engineering can replicate and improve factory parts, the assumption of exclusivity starts to weaken. And that is something the automotive industry has always been careful to protect. Not just performance, not just branding, but control over knowledge, control over repair, control over narrative. This Chiron rebuild is quietly challenging all three. The most symbolic moment of the entire process is still the gearbox bracket, because it represents the intersection of all those ideas. A small component carrying massive structural responsibility, a known failure point that was flagged internally, a part that cannot be purchased directly, and now a part being rebuilt better outside the system that created it. If the new bracket succeeds, it doesn't just fix a car, it proves a concept, that control repair is not the only path, that factory limitation is not the end of engineering, that independent builders can operate at the same level of precision, without the same restrictions. And as fabrication continues, the question that started as curiosity becomes unavoidable. If a crashed Chiron can be rebuilt, if factory-only parts can be reproduced, if performance can be improved independently, then what exactly makes a Bugatti untouchable? The answer, it turns out, was never purely technical. It was structural in a different sense. Structural in narrative, structural in perception, structural in belief. And belief, unlike aluminum or titanium, is much easier to reshape. Now the rebuild moves into its final phase. Everything has been measured, everything has been scanned, everything has been challenged, and slowly the car is beginning to return, not as it was built, but as it has been redefined. And somewhere inside that transformation, one truth becomes increasingly clear. This was never just a repair project. It was always an investigation, and the results are still unfolding. Now the rebuild enters a stage where everything either comes together or falls apart. There is no in-between anymore. Every part has already been questioned. Every system has already been measured. Every assumption has already been challenged. What remains is execution. And execution is where theory meets reality without mercy. The chassis alignment is the first true test. Because once a Bugatti Chiron is split, even perfect fabrication means nothing if alignment is off by the smallest margin. Millimeters become structural tension. Structural tension becomes fatigue. And fatigue becomes failure at speeds this car was designed for. So the process is slow, almost painfully slow. The front and rear sections are brought back into alignment using digital measurement systems, laser referencing, and repeated verification cycles. Nothing is guessed. Nothing is assumed. Everything is checked twice, then checked again. The car is no longer just a machine being rebuilt. It is a geometry problem being solved in real time. And every correction feels like a negotiation with physics itself. Meanwhile, the new gearbox mounting bracket begins to take physical form. Machined from a solid block of aluminum. Not cast, not mold, not shaped by production constraints, but carved by data. Stress simulations define thickness. Load paths define reinforcement ribs. Material distribution follows force rather than convenience. This is the moment where the philosophy of the entire rebuild becomes physically real. Because this part is no longer just a replacement. It is a statement. A statement that factory design is not the final version of engineering. It is just a starting point. Back in traditional manufacturing, cars' components like the original bracket are shaped by process limitations. Molten aluminum must cool evenly. Wall thickness must remain consistent. Internal stresses must be controlled through uniform geometry. It's efficient, it's scalable, but it is not optimized for every possible real-world stress scenario. CNC machining removes that limitation completely. Now strength can exist only where it is needed, and be removed where it is not, which means the rebuilt bracket is not just equal to the original, it is structurally more intelligent, stronger in key load areas, lighter where mass is unnecessary, and more precisely tuned to how the specific Chiron will actually behave under stress. It is engineering tailored to a single outcome, not mass production. As the part nears completion, something interesting begins to emerge. This is no longer just a repair exercise. It is reverse validation of factory design. Every change being made raises a silent question. Was the original design optimal, or just acceptable within manufacturing constraints? And once that question is asked, it cannot be unasked. Meanwhile, the exhaust system is reaching its final form in Texas. The Valvetronic team has transformed the original titanium system into something that still respects emissions requirements, but no longer suppresses the identity of the W16 engine. The restrictive secondary sections have been removed. Flow paths have been reshaped. Back pressure has been recalibrated. And for the first time, the engine is being allowed to express itself more freely than Bugatti ever intended in production form. But even here, restraint still exists, because this is not a loud-for-attention modification. It is a controlled release of what was always hidden inside the system. The sound is not being created. It is being uncovered. Back in Miami, the radiators returned from the UK, repaired, reinforced, reconstructed where necessary. Bob's approach was simple, almost dismissive in its confidence. No unnecessary drama, no over-engineering, just methodical repair of high-performance components that were never as untouchable as branding might suggest. And that, again, feeds into the growing theme of the entire project. Exotic does not always mean unrepairable. Complex does not always mean impossible. And expensive does not always mean irreplaceable. It just means controlled. Controlled by those who originally built it. But control is slowly being redistributed in this workshop. Not through conflict, through competence. The wheels arrive next, designed through a combination of 3D scanning, computational modeling, and physical constraint mapping. Brake clearance is exact. A-flow channels are intentional. Structural load paths are calculated. Nothing is aesthetic first. Everything is functional first. And somehow, the final result still looks like it belongs on a hypercar worth millions. That is a quiet success of good engineering. It doesn't look like compromise, even when compromise is everywhere behind it. Then comes the moment everyone has been working toward without saying it out loud. Rejoining the chassis, front and rear sections slowly move back together. The alignment system monitors every millimeter. The structure settles into place gradually, like something remembering what it used to be. Bolts are inserted. Torque sequences are followed precisely. Load distribution is checked across multiple points. And for the first time since the car was split, it is whole again. Not finished, not complete, but physically unified. And in that moment, the scale of what has been achieved becomes undeniable. A manufacturer declared this process impossible outside their factory environment. Yet here it is, completed, not by replication, but by understanding and rebuilding. But the most important moment is still ahead. The gearbox mounting bracket, the component that started the entire chain of questions, now installed in its new form, machined, optimized, reinforced beyond factory specification. It sits in the exact same position as the original, but it no longer behaves like the original. It behaves like an evolution of it. When load is simulated through the system, the difference becomes clear. Stress distribution is smoother. Weak points are reduced. Structural rigidity is improved. It does not just match factory performance. It exceeds it in key areas. And that is where the real tension in the story reaches its peak. Because if an independent workshop can improve a core structural component of a Bugatti Chiron, then the boundary between manufacturer authority and independent engineering begins to blur completely. Not in theory. In practice, this is no longer a rebuild. It is validation. Validation that knowledge once considered locked inside factory walls can be accessed, studied, and improved upon. And once that line is crossed, it cannot easily be drawn back. As final systems are reconnected, something else becomes clear. This project was never really about restoring a crashed car. It was about testing a belief that modern hypercars exist beyond independent engineering reach. And that belief did not survive contact with reality. Because reality is what happens when you measure everything instead of assuming it. When you fabricate instead of replace. When you question instead of accept. And when you rebuild instead of discard. Now the Chiron stands whole again. Not as it left the factory, but as it has been redefined through process, analysis, and relentless reconstruction. And in that silence before the final testing begins, there is one final truth that settles over the entire project. This car was never unrepairable. It was only unattempted, and that changes everything. Because once something is successfully attempted, it is no longer impossible. It is just the next starting point.